I'm so excited to be here. This is the third time we are meeting in AngularUP for live coding, doing things from scratch, and having a lot of fun diving deep into the internals. And thank you for the great introduction. You forgot to mention one fun fact about me. I also work as a consultant part-time for BlackBerry. כן, הם עדיין קיימים. All right, so today we are going to talk about a few magic tricks that can make you more powerful programmers and developers. And as our tradition goes, let's start with live coding demo. So for the first demo, I just created a new Angular project with a CLI, with routing. So I just did this before the talk because NPM is slow, and now it's ready, it's running, basically a lot of output, and let's go into the directory, and okay. So this is the welcome to app. You probably all know this screen. And the first thing we are going to do, we are going to replace this screen with something more pretty. So we are going to use the Angular CLI to add material design to our app. So I'm going to run this command. How many of you know about this ng-add Angular material? So now all of you can raise your hands because all of you know about it. And basically what it does, it adds Angular material. You can see it updates a lot of files, and then it installs the packages with npm. Let's run ngserve again. And basically, we don't expect to see, okay, I have another ngserve running, so let's live demo killing node. Okay, I forgot to kill the other one, sorry. So I'm going to do it even more brutally then. Just close this window. Let's see if it works now. 3, 2, 1. Well, it takes time, but yeah, it works. Anyway, so we are not going to see anything very much different right now because we still have our app. But let me show you a few more gems hidden in the Angular CLI. So we are going to call ng-generate, and we are going to ask it to generate Angular material of type material nav. Let's give it a name, app nav. And this is a new cool command that generates a navigation bar for your application. Let's see it. Let's start by just replacing all the stuff in our app component with the new app nav that was just created for us. Let's also move the router stuff into the app nav that was created for us. So this whole code was generated by the ng-generate command. Let's call it instead application title. Let's give it Angular Lemala. And now, as you can probably see, if live, okay, so this is what we got. We just typing one command and changing application title to Angular Lemala. But thanks for the excitement, but it gets even more exciting when we start adding more components. Let's add a dashboard, app dashboard. And basically, in order for this dashboard to be shown, we are going to open the routing module that was generated with the app and say that for the empty path, for the slash, we want to use component, and that would be app dashboard that was just generated for us. Saving, and voila, we got a dashboard. Similarly, you probably guess what material table will do. And let's also create a table, add it to the routes, and then we can put it under /table. By the way, this live coding is high risk. Do try it at home. App table component, missing a comma. And in order for us to be able to navigate to /table, let's update these links on the left. The first one will be dashboard, and it will router link to slash. No, I don't want to close this tag. And the second one will be table, and it will router link to slash table. And I think that's about it. Let's go back to our live reloaded app, and we got, I told you it's dangerous. Yeah, I need to go back to the routing and remove the slash. Why are you so picky, Angular? Anyway, now we have the dashboard and the table, and it has nice functionality like sorting, and it's even responsive. So I can basically have this nice behavior, and the dashboard has these nice popovers. Basically, I think this is super nice. So I think the material team deserve a warm round of applause for doing this. Thank you, material team. So how did this all happen? I mean, we just had to type a few commands, and we have a full-blown application. Let me just close the mobile view. So we have a full-blown application with just a few commands, and you can find all the commands here in my slides. I just posted a link to my Twitter, so you can go there later and download the slides. And this will stay here, so you don't have to copy it right now. And the thing is, what we have just seen now is a new feature in the Angular build system. It's called Schematics. Rob mentioned it this morning. And basically, it allows you to build tools that generate code and modify code. So all of these ng-generate that generated a dashboard, a table, and etc. were just schematics created by the material team. And guess what? You can create your own. But here comes a GIF. So basically, as I said, schematics can add dependencies to the project. They can create new files from template, like all the template that was generated for the navigation. And they can also update existing files, which is the most challenging part that we are going to talk about today. For example, when we added the dashboard or the navigation model, we can see that it added a lot of imports, too many. TSLint doesn't like it. It added all those imports to our app module with all the components, the material components that were used there. So basically, schematics are powerful, and you all can write them. And the first two parts are pretty easy. You can follow a tutorial. The other one is a little bit tricky. Let's talk about that. So today's talk is actually not about schematics. It's about efficiency, manipulation, and automation. And what we are going to do today is to see those tools that you can use in order to build your schematics or your own tools that let you modify source code quickly and efficiently. Let's start with something called the AST, Abstract Syntax Tree. How many people are familiar with it? Just a few, not quite a few, just a few. So basically, abstract syntax tree is how TypeScript represents your source code in memory. When you load a TypeScript file before it's converted to JavaScript, it's converted to abstract syntax tree. And it's really useful whenever we want to write tools that modify code. Let's see what it looks like. So when you gain control, when you get familiar with the AST, you can write your own schematics really easily, like adding the imports needed for your module or whatever, like the material schematics just did. You can also create auto-fixes for Visual Studio Code. So this is a link, check it out later, to some intern at Google that published some auto-fix for VS Code that can turn code with promises with a lot of then into async await automatically. I think that's amazing. Check it out later. There is a cool GIF. And you can also do all other kinds of refactoring in your code automatically, like we are going to do right now. So let's get familiar with the TypeScript AST. There are two tools here. The first one is very well known for people who use ASTs. It's called the AST Explorer, and it has one disadvantage. I'm going to show it to you now. Basically, AST Explorer supports ASTs not just for TypeScript, but for many other languages, for HTML, for Babel, for other compilers. But there is a problem. You see, this is the source code, and this is the AST displays. Yeah, I was also shocked by it. It took me a lot of time to get used to working with this tool, which is why I created another tool called TS-Query Playground. We'll get to TS-Query in a moment, but first of all, let's see what the same program looks in the TS-Query Playground, which shows the exact same AST, but in a more concise format. So you see here we have this code, hello world, console log, and on the right you can see the AST generated for this code. So basically we have a source file that represents all of our source code, and it contains one expression statement, which is this line, and inside it we have a function call expression, calling some function. And the function call expression has two parts. So on the right we have this property access expression, which is the console.log, and on the right we have this string literal. Now, can you guess what happens if I change this to, let's say, 12? What will the string literal be then? Right, numeric literal, yes. So basically, AST is another representation of the source code, and the big advantage of working with AST is that you don't have to care about stuff like spaces, comments, different ways to write numbers, like, or I don't know if it's valid one. No, it's not valid one, but this one is actually base 8 or something like that. And there is also this one, and you don't have to care about it. AST gives you, there is some number here. You don't have to care about how it's written. So basically that's a quick overview of the AST, and this is a really useful tool if you are getting into learning the AST. You just write some code and then you see the structure. Which brings us to our next tool, which is called TS-Query. TS-Query let us go over the AST and run a query, like a CSS selector that finds nodes in the AST. For example, let's create a function f, that takes an argument a, and another function g that takes an argument a, and let's also take an argument b. And let's say we wanted to find just the parameters of the function. Let's say that we wanted to do something with them. So we click on A, we see that the AST type is parameter, which contains an identifier with the name of the parameter, and we can see that with this function it has two parameter nodes because it has two parameters. So basically if we wanted to find all the parameters, don't look at my cheat sheet, we just have to write parameter. And I don't know if you can see, but it highlighted the matches A and B. And let's say we only wanted the first parameter, so we can ask for first child, and it would return us just the first one. And last child, and everything you can use with CSS selector. Even more, if we only wanted to query for string parameters, you can see that this is a string parameter, and it has the identifier, the name of the parameter, and the string keyword. So we can ask for a parameter which has a string keyword inside. So it's basically just like running CSS selector, but on your code. So what can we do with this technology? It's cool, but it gets cooler when we are able to run these queries over the entire source code available on GitHub. So another fun project I created, Big TS Query, lets us write such selector and query all the files in GitHub. So since there are a few presets here, and since we are in an Angular conference, I would choose the Vue component. So this is basically querying for all the classes that extends. Heritage clause is just the fancy name for extending something that has the name view. So every class that extends view, and we are going to run this query. It takes a little time since it's searching over 1 million TypeScript files. But basically, if we wanted to know how to write view components, we could just look at those results and find a bunch of real-world view components in the wild on GitHub. But let's say we are just interested in writing stuff that uses the router, so we can query for just components that has a reference to the router that has an identifier inside them called router. And again, this would find view components with any reference to, with any identifier that has the name router. So we are going to run this one. And this is really useful for language, for library authors to see how people use them in the wild, or just for you if you want to learn about how other people use a specific feature of a library. For example, in this case, we found a few matches for the router inside view components. I'm going to open this. I'm not going to open this file because I did back. Yeah, so I'm going to open the first result, and we can see it took me to GitHub to a view component, and it indeed used the router. So I can see how they use the router and learn from what they did here. Or even better, I can learn some Korean, apparently. All right, so that was a fun tool, but let's get our hands dirty with actually using tsquery to write something that modifies code. So basically, if we query and find something that we want to change and then we modify it, that's refactoring. So this is our game plan. We are going to find some relevant code with tsquery. Then we are going to prepare a list of places we are going to change in the code, as these are all the matches. And then we are going to apply those changes and save them back to the file. So load the file, find the relevant AST nodes with tsquery, then replace them with whatever we like, and then save the file. That's simple. And of course, we are going to create a tool for that live. And since this is live coding, we are going to create a small tool. Let's say, let's go back to our AngularUP, and let's say we had in the table component, which is quiet log, the table data source, which was generated by the material schematic and is quite long. Let's say we had a few console logs. Somebody is calling somebody. Let's say we have a few console logs, like we had one here, and then let's say we had one here inside data.sort. And let's say we wanted to, we have all these console logs scattered in our application with all sort of debug data. Some of them are written in even in a fancy way, like with a new line after the console. That's still valid syntax. And let's say we wanted to introduce service that would collect all the logs. So we could try to search and replace the text manually. It would probably break, and we only want to do this in components, not in other files, so only inside classes. So with string search and replace, that would probably be pretty tedious and would probably replace stuff that we don't want in comments or inside strings. So we are going to create a small tool that will use tsquery to find all the console.logs and replace them with awesome logging service.loginfo. Let's start. So live coding is dangerous. Luckily, I got my live coding hat. I'm going to put it on. And now I'm ready for live coding. Let's start with creating a new project, because we love to do things from scratch. Let's make there, call it console log fix, cd console. No, that's another conference. Yes. Open VS Code, and we are ready to rock and roll. Let's create a new yarn project, yarn init -y. And since we want to use TypeScript, I'm going to use some copy-paste. I'm going to install TypeScript and tsquery into my project, and while it's installing, I can create a configuration file for TypeScript, just an empty one. I'm going to create source directory for my source code. And to make it even more awesome, Martin mentioned Jest. If you were here on the previous session, we are going to use Jest to write tests as we create a code. So let's add Jest and a few dependencies. You don't want to add Jest? Okay, let's install Jest. And I need to configure Jest to work with TypeScript. So there is this snippet under tsjest GitHub that I need to copy to my package.json. That's the French version of package.json to set up Jest. Yeah, package, si, oui. Okay, copy paste done, it's happy. And let's create index file, let's call it console fixer.spec. Actually, let's call it console log fix.ts and create a test file because we are going to use test-driven design, fix.spec.ts. And let's start writing a first Jest test. And you know what? While at it, I will also show you another tool called Wallaby. Anybody heard of that? It's amazing. I'm going to show you. Let's start by just copy-pasting their default configuration for working with Jest and starting it. And, oh, yes, I need to select the configuration file. And now it's starting. It will take it a few moments to start while we write our first test. And then we can say it should replace console log with my awesome, let's get this out of the way, service. And basically, let's start with a passing test, expect 1 to be 1. And you can see those green markers. Thus, as I type, Wallaby is running my test code and showing me if it's passing or not. So let's start by writing our test case. We have some inputs. Let's say it will be some kind of component, my component, and it will have a method. Let's call it ng-on-init, and inside ng-on-init, we call this for.foo, just for the sake of it, and console.log, wow, hi, Angular lemala. Yes, and basically, what we expect this to do, we expect to create a console log fix function that takes this input and returns something like basically the same, but just with, instead of this console log, we would like it to contain, let's say, remove this, we would like it to contain, we said this.awesome logging service, awesome logging service, log info. Wow, AngularUP. So basically right now our test fails because we still haven't even implemented a method. So let's create it, export function, whatever, that gets src, and just for the sake of it, it will return src, and then we need to import it in our test. And we have a failing test because it still says console log. You can see the problem here. We wanted this, we got this, but we wanted this. So how would we make it work? Basically, we're going to import tsquery here. Import tsquery from, it has a really complicated package name. I don't even try to read it aloud. And we are going to convert this. Let's just fix the spaces here. Okay, we are going to convert this source code into AST, so we are going to call tsquery.ast with the source code, and then we can run the query. So we are going to call matches equals tsquery.query. We are going to query the AST with some selector. But which kind of selector are we going to use to find a console log? In order to answer that, we are going to go to my component, copy paste it into the playground, and see what console log looks like. So we want console log. Basically, this is a property access this is a call expression, calling a function as we had it before, with a property access expression with the name of console and log. We are accessing console.log, then calling the result with some string. So what we want to find here is all the property, all the call expression. And we can see this also matches this one, which we are not interested in. But we can ask that they have a property access expression with expression.name equals console and expression name.name equals log. How did I figure that it's expression.name and name.name? This is unfortunately not displayed yet in TS Query Playground. You can find it in this AST Explorer expression and name, but it's not important for now. We see that it works, and we also want to only do this inside methods. So we are going to say this whole thing is only valid if we are inside a method. So let's method declaration. And yes, it still matches. Let's just double check. If I change to log, it doesn't match. Now it matches. So basically, this is a query that finds all the console log calls that are inside the methods somewhere in our source file. So let's go back to code, and we can put this expression in. And finally, we have a list of matches. We can actually check that we have matches. And you see this is Wallaby showing me, running the test and showing me the value of matches. Let's also try to print the text of the message. And yeah, it found the console log in this test string. And now what I'm going to do, I'm just going to write some code to replace this console log with this awesome logging service log info. So for that, I'm going to go over the matches. Let's have a result that will be equal to source and return result. And now I'm going to go for const match in matches. So I'm going over each of the matches of my queries, and I'm saying I want the result to be all the text that we got from so far from the beginning until the start of the match. So we are getting all the text before gets. What doesn't it like about it? Match is. Why is it string? For off. Thank you. Thank you, Mr. Key. Yes. Right. So match.getStart. So I'm going to take the source code until the start of the match, so until the console log, and then I'm going to add this. So this is the replacement text, and then finally I'm going to add result.substring, the text from after the console log, so that would be get end after the match, and you can see my function is green, my test is passing. So basically, this is Wallaby just letting me know that my code works. I wrote a test, I wrote a code, and now I know it works. Let's try to break it in some ways. For example, let's see what happens if I put some new lines here. It still works. If I could put a comment here, it doesn't work because I didn't close the comment, but as soon as I close it, it still works. So basically, this is pretty resilient. Let's try to see what happens when I have a few console log. So if I have a few console logs, I just put a new line, so I would expect the result to be like this, right? For some reason, it seems like I'm getting a different result, like something is mixed up here. You see, this second one is mixing up with the first one. This is something we need to pay attention to when we use this technique of replacing text. We want to go from the end to the start. We don't want to replace something at the start because this changes the indexes of all the text that follows it. So in order to fix that, we can just go over the matches in reverse and say matches.reverse, and voila, our test passes again. So basically, we wrote a small utility from scratch that takes your source code, runs a query, and replaces something that we were looking for with something else. Now we are going to run it. Okay, I didn't want to do that. I'm going to open it again. We are going to conclude this demo. I have 3 more. Thank you. So we are going to run this demo. Let's just create let's just create a small index file that runs this demo. That would be console fix console log index, and I called it console log fix. Basically, it reads a file, applies this function, and writes the file again. So yes, so let's run this with a tool called tsnode that allows us to run TypeScript code without compiling it first. And we had this file with all those console logs that we created before. So let's pass it as an argument. Okay. Pam, pam, pam. So we are passing it to our tool. And if everything works well, we got no error. And we should see the console logs that we had replaced with this.awesome logging service. So it worked. Now I'm going to do the silliest thing to make this thing actually work and say that log info is actually console.log, just so it compiles. Oh, without this. Okay, so it compiles again. So that was a quick demo, and now for our final super quick demo, in which I'm going to show you some tool that I created with tsquery that is called typos. And if we code back to our code, we can see that this generated code had a method called compare. And this compare method takes 3 arguments, but none of these arguments have types. So basically what typos does, it uses tsquery to add console logs when the code runs. It finds out the types of the arguments, and then it updates the source code. Let's see this in action. We are going to install typos webpack real quick to our project. This is the webpack integration for typos. Thank you. I need 1 more minute. npm, okay. We are going to run typos Angular to set up the project. We are going to restart ngserve. And now what we are going to do when it runs, we are just going to go back to the project, to the web page, just play with the table and see how typos does the magic and figure out the type for these arguments. So let's go back to the project. Let's just refresh, make sure it's up. Go back to the table, and we are going to just, play with the sorting a little bit. Angular Lamala, so it should be sorted up, right? And then we are going to ask typos to update the code. So we are going apply types with collected types.json, which is a file that generated all the console logs that we added, the typos added to the code. And nothing happened. Oh, I know why, because, let's go back to the file. Okay. And live demo number 2 failed. Oh, it worked. I said it failed, but it worked. Yeah, it added the types. So you can see it figured out this could be a number of string, this a number of string, and this could be a Boolean. So basically, we use typos at BlackBerry 3 of my colleagues from BlackBerry are here, by the way. We used typos at BlackBerry in one of our projects, and that was the result. Annie was gone. So a few more links. You can learn more about TS Query, about schematics. This is a great talk by Manfred Sattier, and about typos, of course. And what I want you to take home from here. AST is awesome. Most of you have never heard about it before, but it's super powerful. You can build tools like the one we live coded here, and like typos that I just showed you, with not too many lines of code. So write your own schematics for yourself and your team to be more efficient. You can write TS-lint rules with these tools, whatever you want, and be creative. Code automation saves a lot of time. So thank you. And the Tavon.